Hey, I'm Dr. M. Kamakshaya. Welcome back to my video demonstrations related to R programming language. I've been explaining about business analytics for the past few videos. In my last video, I explained how to deal with ANOVA. That was a bit lengthy video demonstration, but in this video, I'm going to show you how to perform MANOVA. And this is hopefully this video is going will be very short in its size. If you remember, in my previous sessions I was dealing with some behavioral data set, and this is actually a sample data set in which we have few socioeconomic characteristics and also a few study characteristics. Now if you remember exactly, when I was performing the t-test, I was trying to, it is not exactly t-test, but I guess chi-square test. I was trying to select one particular variable of a factor, and then this is actually, you see there are three factors in this data. There are three variables corresponding to a factor called satisfaction. There are three other variables, they correspond, three of them corresponds to a factor called perception, and there are three variables which corresponds to a factor called attitude. So we are trying to study the satisfaction, perception and attitude with respect to some socioeconomic characteristics. Now you see here actually performing analysis on one particular variable from a factor against a particular other socioeconomic variable does not make sense. I don't think that. So we need to perform the analysis on the total factor against any given socioeconomic variable, or maybe the set of socioeconomic variables. So that makes really sense. I mean, that makes quite a bit of sense while performing the analysis on this type of data sets. Now, if that is the question, like suppose you are in a situation where you can't select one random variable against you are in a situation where you need to do some analysis of variance, and where you have few factors, and your interest is to analyze the factors against socioeconomic variables, factors, then the right technique can be MANOVA, not the ANOVA. In ANOVA you have one single variable at LHS and a couple of variables in RHS. And if you don't know what is LHS and RHS, you have to refer to my previous video. We have a definite way of now I'm going to show you how to perform MANOVA on this data set. For that, by the way, if you want to learn what is MANOVA, the very best place can be Wikipedia. Okay, now I know many of you might be scolding me for referring Wikipedia. I like it because I am open source software evangelist, and Wikipedia is open source knowledge management systems. They are working very hard, and their efforts must be their efforts are very significant in academics and as well as in industry for that matter, because I personally salute the Wikipedia team for their efforts. Many times I just go to Wikipedia for a quick understanding on any mathematics and statistics, even for that matter any kind of body of knowledge. If you don't like it, I don't care. You can just go to any, if your teachers tell you to use any novel, archaic, classical textbooks, maybe you can just go back. But I prefer Wikipedia. So I want to use Wikipedia for after all they are my demonstrations. I like to do whatever I want to do. So if you really repose your confidence in my demonstrations, you need to follow my instructions. Now in Wikipedia, there is a page for multivariate analysis of variance. You can just pick up the definition here. I think this is more than sufficient. Even I understood what is MANOVA better in this web page than in a textbook. I never got anything from the textbook. I was not able to make in and out of the text given in the textbook. It was very difficult for me to comprehend. Maybe I'm not as intelligent as so-called teachers in the. Now these are the methods in MANOVA. We have to perform, I mean this is actually the statistic behind. We need a statistic and a p-value to take a decision on any after performing analysis. I mean we can, there are many ways to interpret the outputs, but I prefer p-value to make the inference or make the decision on the data. Okay, now this is the sort of this is called Pillai trace and lambda Pillai, and this is the objective function for this, and I spoke about all these things. I didn't talk much. In MANOVA what happens, actually there is a hypothesis. I mean the null hypothesis is that the sigma model, sigma means the variance matrix. I mean it is called it's not exactly the variance matrix, it should be variance covariance matrix. I think you see it uses the covariance between outcome variables, and yeah, it is the, I mean usually the sigma is denoted, I mean referred to, most of the time the sigma refers to variance covariance matrix. If it is not variance covariance matrix, it should be covariance matrix. Okay, that, and finding the covariance matrix, you just need a spreadsheet application. It is that easy to find out the covariance matrix. Now the null hypothesis is that for MANOVA is that sigma model is the assumed I mean our assumptions. Suppose if you have a model for your assumptions and that model is equal to the sigma residuals, I mean the error. I mean the covariance matrix, covariance is actually the variance explained by the model. Suppose if you have your assumption, and what is the support of like the variance is actually the amount of information which is supporting your assumption. That is what is called the model. Now this is the residual variance, the covariance matrix of the residual is the amount of information that supports the error. So we assume something, and how much of the information is in support of our assumption, and how much of the information which is against our assumption. That is what is the expression, meaning behind this expression. Now the ratio of these two measures should be 1. So that is what is actually the null hypothesis. If you are not understanding what I am talking, just forget this. You don't need to. I am just going to explain you the MANOVA without. That is why you don't need to touch the methodology or methods. Please be always because you are not going to be the statistician, and at least you are not a mathematician. You don't need to worry about all this. You just have to believe in your. You just have to know what is the null hypothesis and the alternative hypothesis. And in MANOVA, null hypothesis is once again the same. Like I don't have the. Like let me take to the. See, this is what is null hypothesis. The mu values at LHS is equal to the mu values of the RHS. That is one. Suppose if you have n number of variables, suppose you have something, you know, x1 plus x2 plus x3, then is equal to y. I mean, sorry, I have to go. Okay, no, I'm not going by the convention. y1 plus y2 plus y3 is equal to x1 plus x2. Suppose if this is what is your model, and now the mu values of mu of y1 comma mu of y2 comma mu of y3 is equal to mu of x1 plus like you can also comma mu of x2 plus comma mu of x3, something like that, or mu of y1 plus y2 plus y3 is equal to mu of x1 plus x2 plus x3, something like that. So the averages, I mean the expected value that represents the LHS should be equal to the expected value which represents the RHS. That is what is the statement of the day. Okay, that is, this is referred to null hypothesis. I don't know why this is not coming here. This is called null hypothesis. So you just have to know what is the null hypothesis. You don't need to worry about the methodology behind the entire MANOVA. And then the alternative hypothesis is that at least one mean is not in agreement with this, I mean not equal to the other means of the LHS. And now please be mindful, the RHS you have the study variables, and LHS you have the study variables, and RHS you have the socioeconomic characteristics, your socioeconomic profile. In this data we have two parts. The first part is the socioeconomic profile of the sample individuals, and the second part is the study interest. Now our model is going to be SAT1 plus SAT2 plus SAT3. Suppose if you want to perform analysis between satisfaction versus gender plus age. Now your model is going to be SAT1 plus SAT2 plus SAT3, which stands for satisfaction. So the satisfaction is equal to gender plus age, or plus salary, or plus family, something like that. Now let me start our analysis. That is all introduction. So let me clear I think clear is not valid, control L. Yeah, now we need to take the data inside behavioral dat is read CSV file shows. Okay, now press enter, and this must be able to start the in Linux we call it as earlier we used to call it as Nautilus. I think now this is X window system. You got window to open your data sets, and in data you have that where do you have it? I think this one is the data. Let's see if this is the data or not. Now names behavioral data. Yeah, you have the data here. Now we got the age, and now our assumption is going to be we are going to analyze between my LHS is going to be like that. I call it as Y combine SAT1 plus SAT2. Yeah, I cannot do. Yeah, let me do this SAT3. Perhaps I need to go for SAT1 is not found. Yeah, correct. Now let's do one thing. Shall we do this? I call attach behavioral data. Now I can do this. Yeah. Now my X I don't need to make X. Now straight away I can go for fit MANOVA dot fit. Let me call fit. Now MANOVA. Suppose if you don't know what is MANOVA, then go for help. If you don't know the syntax for MANOVA, you can do this. You have a help file here. Just you can read what is MANOVA in R. Okay, till now we read what is MANOVA in general, the methodology behind MANOVA, and now this is the procedure to perform multivariate analysis of variance in R. This is syntax. You don't have much documentation here. This is the base. I think, yeah, stats. You have a package called stats already attached to your session. You don't need to attach this separately. So MANOVA is available straight away for your analysis. Now these are the examples. You can spend some time and read these examples and understand what is MANOVA, and straight away performing MANOVA here. So MANOVA fit. This is just a user defined object. Left assignment parameter and MANOVA. So this is the function. Now Y depends on what? Sorry. On what? On gender plus age. Now we can also define the interactions, and suppose if you want to go for the interaction between gender and age, maybe together they also influence this satisfaction. This is the main effect from the gender, main effect from the individual effect from the gender, individual effect from the age. This is the combined effect, something like that. Now data is behavioral data. If I don't have the error in my, mistake in my statement, I should be able to, yeah, I got need multiple responses. Where is gender behavioral data? Need multiple responses. I think this one. So at times I also prefer when I do mistakes, don't worry. Now let's go for, instead of Y I say C. I think C bind. I'm sorry, so I did a mistake here. let me go for, this is not C actually, C bind. Yeah, now I think now I can do this. Why gender MANOVA? In MANOVA need multiple responses. Why? I have everything okay. Why it is why? Oh, sorry. Think it is only taking the first one. Yeah. So when I was doing this, I told you. So there is. Let us use the indexes. Think we got SAT1, SAT2, SAT3. What is this? This one is 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. That is going to be. Let's say, yeah. Let me go back to this. Yeah, here I come. Let me use behavioral data. That then you got this in single quotes or double quotes, whatever it is. Behavioral that. Behavioral that. Then you have this in. Let's say this, and then behavioral that. I'm just using the slicing. Okay, this is what is called slicing in R. You can also use numbers, then it is called indexing. Yeah, why? Now let's, I don't know, I'm just trying to do this. Invalid type list for variable y. Why? Shall we go for, let me try a number of ways. This is going to be 5, this is going to be 6. Oh, I think I have to convert that into, let's see, don't worry. Why now? Why? Oh, I'm sorry, I'm a fool because I'm using plus here. I cannot use plus, it is comma. Sorry, let's go to the first one. Think C bind, SAT1, SAT2. I'm still down because these are only names, they are not variables. C bind y. Yes, now you got it. This is how you have to do. So I was doing a mistake by putting plus. Anyway, I do many mistakes. I'm not shy of doing. I learn only by doing the mistakes. Now let's go for MANOVA this time. Yes, we did this. Okay, now MANOVA fit. We got wonderful. We got output here. Now you see for SAT1, you got coefficient, and you got, this is the coefficient for gender. For SAT1, you got the coefficient for gender, coefficient for age, and then coefficient for the interaction, and then coefficient for the residuals. In other words, we also sometimes refer this as an effect. There is an effect for satisfaction. I mean the variable. This is the factor. All three together is a factor. So these are the coefficients for each of these variables of factor satisfaction against gender, against age, something like that. Now you have the residual standard errors for each of these. You know, this is for gender, this is for age, and this is for age, I mean interaction effect. Now this is not the, as I had explained in my previous demonstration, this is not the actual, this is only to know the effects. You see here it is positive and it is 0.3. At best it is going to be 0.9. okay, and this is 0.01. This is not as strong as satisfaction 1 for gender. And you see here satisfaction 3 and satisfaction 1, both of them have strong loadings for gender, and satisfaction 2, I think there is something went wrong in case for satisfaction 2 versus gender. The value is very less. Now the same way you have, here you have 2.8, it's very strong. You see here it is 11.42, it is very strong. This is not 0 to 1 as most of the times. You can also have more than 1. The very stronger value, the maximum value for satisfaction 3, little lesser, and this is far less. but for gender both SAT1 and SAT3 has good value, but in no case we have minus. That is what you need to find. Now let me use summary method on MANOVA fit. Now this time you should be able to get the ANOVA style table. ANOVA, this is called ANOVA table. It's not ANOVA table, it's a MANOVA table, but you got the F statistic here. See, where is the F? Approximately F. This is F statistic and this is the p-value. So we are not interested in this. This is only useful to get the strength of the relationship between each of these pairs. Okay, but this is what we are interested in. To now come straight away to the p-value, pick the p-value straight away and then compare this with the threshold value. The threshold value, as usual, the benchmark. I mean, that is not scientific, but most of the time commonly accepted value is 0.05, which is 5%. So at 5% significance level, so we fail to reject the null hypothesis that the difference between gender to that of the entire factor, not to satisfaction 1. Please be cautious. Now it is a factor. So the difference between the mean values, the mean value which represents the entire factor, to that of between the gender, the mean value which represents the factor, and the mean value which represents the gender. Now let me not call it as mean. The expected value of this factor and the difference between the expected value of this factor and the expected value of this gender is not statistically significant. So they are more or less same. In this sample, it is, we can, the end of the day, the final observation is that gender is useful for us to understand the satisfaction. So that is what we can conclude or take the decision. The p-value is, so when the mean value of this factor is equal to the mean value, what does that mean? It means that the gender explains the satisfaction. So it is useful for us to understand this factor satisfaction. If the p-value is less than 0.05, then the gender is not useful for us to understand the satisfaction. So in other words, it is not totally true, but roughly there are intergender differences. The intergender differences to this factor satisfaction are not significant. So that is what we can conclude. So it doesn't matter if it is male or female, but the gender in total, as in whole, gender is quietly useful for us to understand the factor satisfaction. Now you can also see all the p-values are greater than 0.05 and they are very close to 1. So they are very strong. They strongly represents this all gender, age, and the interaction effect also. You see, forget about the individual effects, even the interaction effect is also seems to be important to understand the satisfaction for the value is far high compared to threshold value, which is 0.05, 5% significance level. At 5% significance level, we can conclude that the gender, age seems to be very important in understanding the satisfaction in this data. Okay, that is how we can perform the MANOVA, and this is it for this video demonstration. And I will come back again with some other statistical technique. Okay, thanks for watching my video. Please press like button whether you like it or not, and sorry for talking like this, and subscribe to my video channel. Stay tuned for the new content. Thanks once again for watching this video tutorial.